In this video, we're going to talk briefly about the different analysis methods we have for our frame-generated components inside of Autodesk Inventor. Here with the Frame Analysis IAM from our Working Files directory, I'm going to go to our Design tab and expand the Frame panel. Here we will find the Beam and Column Calculator as well as the Plate Calculator. The Plate Calculator is simply just that. It only calculates based on input information to the dialog box. The Beam and Column Calculator is a little bit more specific to our frame-generated model. Here, when you select on the Beam and Column Calculator, you're able to select an object for reference. Here, I'll choose the back portion of the trailer. I can also flip the section around if need be. The information that it automatically pulls in from that member are things such as the section length, the section area, the section moduluses, moments of inertia, torsional section moduluses, torsional rigidity modulus, and the shear displacement values. I can also tell whether this will be a beam calculation or a column calculation. That will depend on some different changes here in my different tabs. I can also assign a user material by picking any one of these values and modifying them. If I select the radio button, I can pick a more prudent material from a quick pick list. For now, I'll choose OK and uncheck this, and you can see I can fill in whatever values I want in these remaining boxes. On the second tab, we have the beam calculation. Here I can apply loads and supports. If I choose to apply loads, I can do radial force, axial force, continuous loading, bending moments, torques, and common loads. If I choose supports, I can add in freestanding supports or fixed supports, as well as restraints. If you have all your information filled in for your beams, for where your loading will take place, as well as your supports, you can click on the Beam Graphs tab and calculate this based on whatever you've placed into your particular dialog box. The column calculation is not available because I did not choose that option on the first tab. For now, I will cancel this to close out of there. A little bit more of an FEA methodology would be our frame analysis tool. This is a different command we have up here. So we'll choose frame analysis. This will start an environment to Autodesk Inventor that was included a couple years ago. It was a separate piece of technology that Autodesk owned called Robot Structural Analysis. And this has been incorporated into Inventor as well. Inside of this, we have a node-based FEA environment, where it takes the end treatments and the existing members that we have and creates these rigid links between them so it understands how these members go together. You don't have to say that that part is welded. You can just say that it has a rigid link. You can also adjust your links by releasing degrees of freedom, creating custom link information, or applying a manual rigid link where no one existed before. A couple of things to be aware of as the members get translated into this environment. It only works on straight beam node elements. So these curved elements that I have in here for the wheel wells do not calculate into frame analysis. I would have to substitute those out with individual straight links if I need to analyze those. My first step in here is to add constraints, such as fixed constraints, to different areas of the design. Here I'll add a fixed constraint to where the trailer will hook onto a hitch, and another fixed constraint where the wheel wells are at. Now, it's not going to give me a really great representation again because I don't have anything really connecting between them, so I really should create a rigid link between these. So here I'll do a rigid link with my parent node and then my child nodes for this. I'll do another parent node here and another set of child nodes there. So those are all showing connected together. If I expand my rigid links and scroll down, I'll see rigid link 27 and 28 have been created. Once you have your links and your constraints in place, the next thing you need to do is start applying loads. And we can do that with a force load, continuous load, and moment loads. As just a quick example, I'll apply a continuous load to this member here. You would get a box that pops up allowing you to adjust the amount of pound force per square inch you have, or whatever your unit is depending on your assembly. If you zoom in here, you can see you can adjust the angle of the plane of the continuous load. You can also move the nodes so they don't need to take place on the entire length. You can have them just be on one portion of it. If you want more precise input information, you can right-click and choose More Options. And this will open the dialog box to fill out the magnitude for the beginning and end, the angles, custom sizes as well. For now, I will just choose OK. There's not a lot of force acting on this, so if I do run the simulation at this time, it'll go through and analyze what that is and give me beam graphs and different information about the results of the force acting on this system. We then look at those results through our beam details, our probings, diagrams, animations, and the rest of the commands we see inside of this environment. So if you really like the frame analysis tool, remember, you just need to have Content Center generated members in order to utilize this, and no better way to do that than with Frame Generator.